Good morning, everyone. This is Kavita, working as an assistant professor in the Department of Civil Engineering, KPR Institute of Engineering and Technology, Coimbatore. I'm going to take this video on prefabricated structures. See, in this unit 1, these are the topics we are going to see. One is general civil engineering requirements, specific requirements for planning and layout of prefabrication plant, IS code specifications, modular coordination, standardization, disunity of prefabricates, production, transportation, erection, stages of loading and codal provisions, safety factors, material properties, deflection control, lateral load resistance, location and types of shear wall. So in this, what is prefabrication? See, when you compare to conventional concrete, prefabrication is the one which we are doing assembling the components. So we can do everything in a factory instead of doing it in the site. Everything we can do it in a factory, and we can transport the complex assemblies or sub-assemblies to the construction site where it is to be located. So these are the some of the process of the prefabrication. One is we can make a large units of buildings or produced in factories to be assembled ready-made on the building site, and this technique permits the speedy erection of very large structures. Units may include doors, stairs, windows, wall panels, floor panels, roof trusses, and even entire buildings also. So why we have to go for prefabrication? The fabrication is main thing is the cost. So we can reduce the cost, at the same time we can improve the quality, at the same time the construction speed up we can process also. We can use available local materials with required characteristics to use the material which possess the characteristic like we can do a lightweight, easy availability, thermal insulation and non-compressible also. So some of the advantages of prefabricated structures, one is self-supporting ready-made components are used. The need for work shuttering and scaffolding is greatly reduced. So construction time, because of that, the time is getting reduced and the buildings are completed sooner than the capital invested, and on-site construction and congestion is also minimized. Quality control can be easier in factory assembly line setting than the construction site setting. Prefabrication we can locate it where the skilled labor is more readily available and cost of labor, power, material, space and overhead and or lower. Time spent in bad weather or hazardous environment, construction site is also minimized. So careful handling of prefabricated components such as concrete panels or steel and glass panels are also used. Attention has to be paid to the strength and corrosion resistance of joining of the prefabricated sections to avoid the failure of the joint. Similarly, leaks can form at joints in prefabricated components. Transportation costs may be higher for voluminous prefabricated sections than for the materials for which they are made, which can be often be packed more efficiently. Large prefabricated structures require heavy duty cranes and precision requirements and handling to be placed in position. Large group of buildings form the same type of prefabrication tend to look drab and monotonous. Local jobs are lost. So because of that, the local jobs can be lost. Why we can use prefabrication? The most widely used form of the prefabrication in building and civil engineering is the prefabricated concrete and prefabricated steel section in structures where a particular part on form is repeated many times. Pouring concrete section in a factory brings the advantages of being able to reuse mold, and the concrete can be mixed on the spot without having to be transported to and pumped bed on a congested construction site. And a prefabricated steel section reduces on-site cutting and welding cost as well as associated hazards. Prefabrication techniques are used in the construction of apartment slabs and housing developments with repeated housing units. These techniques we can use in office blocks, warehouses and factory buildings. So prefabricated steel and glass sections are widely used for the exterior of the large buildings. Prefabricated bridge elements and systems offer bridge designers and contractors significant advantages in terms of construction time, safety, environment impact, construct liability and cost. Prefabrication can also help minimize the impact from bridge building. Radio towers for mobile phones and other surface often consist of multiple prefabricated sections. Prefabricated has become widely used in the assembly of aircraft and spacecraft with components such as wings after being manufactured in the different stages for the final assembly site. The theory behind the method is that time and the cost is saved if the similar construction tasks can be grouped and assembly line techniques and can be employed in fabrication at a location where the skilled labor is available, while congestion at the assembly site which wasted time can be reduced. The method finds application particularly when the structure is composed of repeating units or forms or while the multiple copies of the same basic structure are also being constructed. So the main application where we can use the prefabricated structures is we can use it in pipes and tanks, poles, pipes, sleepers and pavements, lintel beams, beams and girders, building blocks, wall panels and manhole covers. So these are some of the prefabricated elements. One is for we can use it for flooring and roofing system, precast beams, precast columns, precast wall panels and precast slabs. These are some of the stages involved in prefabrication. The structure is divided into number of units. The different units are precast in permanent factories. It is plant fabrication or temporary plants. We can call it as a site prefabrication. And we can transport to the site. Now here the main thing is, one is the hoisting. The hoisting set it into the final place and we can finally assemble to form a complete structure. So these are the types of prefabricated components: reinforced pre-stressed concrete channel unit, reinforced pre-stressed concrete slab unit, reinforced pre-stressed concrete beams, reinforced pre-stressed concrete columns, reinforced pre-stressed concrete hollow core slab, reinforced pre-stressed concrete wall elements, reinforced concrete waffle slab or shell, hollow or solid blocks and battens, precast blanks and joists for flooring and roofing, precast joints and trussed girder, lightweight or cellular concrete slabs. Precast lintels and suggers, reinforced pre-stressed concrete trusses, reinforced pre-stressed roof purlins, pre-stressed concrete L panel units, prefabricated brick panel unit, prefabricated sandwich concrete panel, precast foundation. And these are the types of the prefabricated system. One is partial prefabricated system, full prefabricated system, large panel prefabricated system, and box type construction. So open prefabricated system we can classify it into partial prefabrication and a full prefabrication system. This system basically uses precast roofing and flooring components and minor elements like lintels, kitchen shells in conventional building construction. The structural system could be in the form of in situ framework or load bearing walls. So in full prefabrication system, in this system almost all the structural components are prefabricated. So another one is large panel prefabrication system. This system is based on the use of large prefab components. The components used are precast concrete large panels for walls, floors, roofs, balconies, staircases, etc. The casting of the components we can do it in the site or off at the site. Depending upon the extent of prefabrication and a full prefabrication system, it can be classified into precast walls. So based on the structural function of the walls, the precast wall may be classified as whether we can make it as a load bearing wall, non-load bearing wall or shear wall systems. So based on the construction, the precast walls may be classified as homogeneous walls, non-homogeneous walls. Homogeneous walls means it may be a solid. Non-homogeneous will be it is like a sandwich panel. So it may be a wood with a concrete or a concrete with a steel like that. Then external wall system and internal wall system also. Precast floors. Depending upon the composition of units, the precast flooring units must be classified into homogeneous floors, which may be a solid slabs, poured slabs, ribbed or baffled slabs. A non-homogeneous floor, which may be of a multi-layered units with a combination of lightweight concrete or reinforced or pre-stressed concrete. Depending on the way of load transfer, the precast floors may be classified as one-way or two-way. When it comes to one-way, it may be comes under the category for hollow core slabs, channels, and lightweight blocks. For two-way slabs, it transfers the loads in both the direction. Cantilever components, it is supported on one edge and other edge without support also. So staircase system may be a single flight with inbuilt risers and treads in the elements. These flights are normally unidirectional, transferring the loads to the supporting landing slabs or load-bearing walls. Another one is a box-type construction. In this system, room-size units are prefabricated and erected at site. Toilet and kitchen blocks may be also be similarly prefabricated and erected at site. Thank you.